Okay. Good morning, everyone. Now I can speak. Good morning, everyone, and welcome to the Faculdade de Motricidade Humana, in English, Faculty of Human Kinetics. Welcome to the pre-conference of Powerpenia. Okay. 2 minutos. Okay. We need to wait because we need to record the session. So just waiting for the signal from the Regi, and then we will start. So, once again, welcome everyone. And thank you for attending to the pre-conference of Powerpenia. Welcome to the Faculdade de Motricidade Humana. And thank you very much for deciding to attend to this conference. I know that some of you come from very, very far away from here. I heard that Sandra already told me that people come from South Korea. I think it's the longest country that we have here represented. Well, during this session in the morning, the main goal is to present a little bit what are the laboratories, some of the laboratories that we have here in the Faculty of Human Kinetics, what kind of research we do here, and just to tell you that currently we are in a process of changing, because as you may see here in the left hand, we are building new facilities, an entire building with a budget of 14 million euros, all dedicated, 3 floors, all dedicated to research in human movement in the several areas that we have it here: exercise and health, motor control, biomechanics, pedagogy, whatever. Okay, so during this session in the morning, Sandra asked us to present a little bit what we are doing here concerning research. And now I will not take much longer. I will pass the microphone to Annalisa Silva, which is the coordinator of the Laboratory of Exercise and Health. And I hope you enjoy this morning until lunch. Okay, thank you very much once again for attending the pre-conference.
So, good morning, everyone. I'm delighted to present the Exercise and Health Laboratory. Our laboratory focused on understanding how exercise interventions and physical activity in general can impact certain physiological markers in health and disease. So, rather than working with a single methodology, we work with a set of advancing methods that can assess energy expenditure, assess energy metabolism, body composition, and several other markers of health and diseases. Our laboratory brings together researchers, clinicians, and PhD students, which are the foundation of the studies that we conduct in our laboratory. And we work under 5 lines of research. As you can see here, we have a line related with functional body composition and energy balance regulation, physical activity and musculoskeletal health, exercise and cardiovascular regulation, physical activity, nutrition and obesity, exercise and endocrine and metabolic diseases. So these lines, they are complementary and they are interdisciplinary. And one of the interesting things is that this dynamic nature of the research lines also allow us to conduct other research projects. For instance, on exercise oncology, we have Inês Correia, PhD student, Marita, Ana Bernardino, that also perform their research under the exercise oncology. And the idea is to better understand the biological mechanisms through which exercise interventions impact and promote health and can also prevent and manage certain diseases. One of our major strengths is having this stable mass spectrometer. We have analyzed routinely total body water assessment through deuterium dilution, and also we were able to use the reference method for assessing total energy expenditure in free living conditions. And this was possible because we implemented the doubly labeled water, which is a method that combines dosing the subjects with two stable isotopes, deuterium and 18O. By dosing the subjects and by the rate of elimination of these isotopes through a certain period, for instance 1 week if they are very active, we are able to understand how the rate of elimination of these two isotopes happen. There's one isotope that is faster than the other isotope in the way is read out of our body, and the difference is explained by the CO2 production. And based on that, we are able to determine total energy expenditure in free living conditions. So after we implemented this method, this supported several international collaborations. One of the collaborations is indeed an interesting one because we now belong to the International Atomic Energy Agency, to a consortium, the doubly labeled water consortium. We also have an ion chromatographer, and we can assess another water pool. So I mentioned before that we were able to determine total body water through deuterium dilution. Now, with this ion chromatographer, we are able to also determine the extracellular water, because we dose the subjects again, but with another method. We use bromide dilution. And the bromide dilution, when we intake bromide, the bromide will be in equilibrium with our body, just in the extracellular water. So, using this technique, the bromide dilution, we are able to determine the extracellular water. So if we have the total body water and the extracellular water, then we are able to determine or calculate as the difference the intracellular water. And sarcopenia involves decrements in intracellular water and increases in extracellular water. Aging is a companion by increases in extracellular water and in the ratio between ECW by ICW. So these are very interesting markers that can be used to monitorize, for instance, the exercise interventions in aging populations. Along with the quantification of water pools, we also have the quantification of our hydration status, which is a little bit different. I know, for instance, that I can have my quantification of total body water, for instance, as 40 kilograms of water that I have in my body, and nevertheless, I may not be hydrated. So we have an osmometer that allows us to determine the actual hydration status by using fluids such as plasma, saliva, or urine samples. Either fluid can be used to assess our hydration status. Very recently, and it is still unpacked, we received the liquid chromatography mass spectrum, so the LC-MES-MES. This will open new avenues in our research because it will allow us, and this will be the first technique that we will implement, the calculation or estimation of skeletal muscle using the D3 creatine method. It's also a kind of isotope, a stable isotope that is dosed to the subject, and we are able, using a specific protocol, to determine the total skeletal muscle of the body. So again, research avenues for studying sarcopenia. We also can, using this method, We can also assess a couple of metabolomics and proteinomics that are useful when we are researching and understanding the mechanisms underlying exercise interventions and the way that exercise helps on prevent and manage certain diseases. We have a DEXA for a long time, and DEXA allows us to assess total and regional body composition, but also, and it was first conceptualized with that M, to assess bone health, fracture risk assessment. Again, an important method to use when we are monitoring older patients or older populations. Now, and still unpacked, and you will see it probably in the wall, in one of the halls of the faculty, we recently acquired the peripheral quantitative computer tomography. This will give an extra information and an important and qualitative as well information about bone geometry, muscle cross-sectional area, and it will be another important contribution for the study at the tissue level of the body composition changes that may occur as a result of exercise interventions. I place it here, but the air displacement plethysmography is basically a body composition technique allowing us to determine body volume and body density. In the past, usually we obtained these measurements through hydrostatic weighing, which was not as feasible as it is now the air displacement plethysmography, because it's easier to have it in our lab settings instead of having an hydrostatic weighing method. Another particular interesting fact, the reference method to assess fat mass and fat-free mass is not the dual energy X-ray absorptiometry, DEXA. DEXA is not really the reference method. The reference method that we use in our laboratory to determine fat and fat-free mass is the 4-compartment model. And internationally, we are one of the labs that enables the use of the 4-compartment model, which is the less assumption method to determine fat and fat-free mass. And for that to be actually possible, we need body volume from air displacement plethysmography, we need total body water from deuterium dilution, and we also need bone mineral content from DEXA. These 3 measurements are necessary to have the right assessment, the reference method for assessing fat and fat-free mass, which is the 4-compartment model. This is something that I need to, I mean, it's important to discuss a little bit. We have conducted several research studies using bioelectrical impedance analysis. And in fact, because we have the reference methods, and this is just a field method, we were we attracted the industry and we were contacted in order to even to validate or develop and validate algorithms for certain bioelectrical impedance devices. We conduct several studies where we obtain the raw data from bioelectrical impedance analysis and of course the derived body composition from this method, the BIVAN analysis, and now we also are going to start some localized bioelectrical impedance analysis. Another thing that I want to call your attention to is the BIA International database. It's hosted in our laboratory and it's coordinated in our laboratory. And it comprises measurements of all over the world. So BIA data collected in Burkina Faso, BIA collected in Japan. So BIA data, raw data and derived body composition, and even DEXA when it's available. And we now have more than 300,000 measurements of body composition and BIA data all over the world. And we are managing this huge data set. That will be very important because it will enable us to harmonize body composition and body composition methods, in this case BIA devices, enabling scientific discoveries. We have even the possibility for requesting the data, and we have a management group that analyzes your request to analyze our data. And if it's feasible, we can share the data. You can just Google BIA International Database and you can access our website. These capabilities are also complemented by wearable and digital health technologies that enable monitoring total energy expenditure, physical activity energy expenditure, physical activity, sedentary behavior patterns, even sleeping patterns by using this accelerometer data, accelerometry, and the lab is also a contributor to an international consortium, which is the Interlife Consortium, for advancing the standardization and validation of wearable technologies so that we can improve health, digital health, and physical activity assessment. So finally, we complement structural assessments with functional assessments. And nowadays we have an ultrasound. We just received it. A better one was received very recently, which allow us to perform Doppler and elastography-based assessments, muscle architecture, quality, and tendon morphology. We also have, let's say, a respiratometer, which allow us to assess mitochondrial respiratory function, cellular bioenergetics. This method has just been implemented very, very recently. And we also assess both resting energy expenditure using indirect calorimetry and also cardiorespiratory fitness assessment. So to conclude, what distinguishes our lab is not a single technology, but the integration of complementary methodologies across multiple biological levels. And we can see from molecules and cells through the skeletal muscle and body composition at the tissue level, and also whole body metabolism and even some indicators of performance that are assessed. So the integration of this phenotyping approach enable us not only to describe the physiology, but also, and more importantly, to better understand what are the biological mechanisms behind the impact of exercise in specific diseases. And our goal is to bridge the fundamental and applied research by combining these advanced technologies in clinical relevant settings, and everything that we want to test is related with the impact of exercise interventions, physical activity on the management, prevention and management of diseases. So we are looking forward to establish new opportunities of collaboration. So I will be at the conference, and if you are interested, please let me know. We can perhaps develop some collaborations or future collaborations. Thank you very much.
Consigo, os slides é que não são os meus. É difícil apresentar estes. O laboratório de comportamento motor é o que está com o Canvas. É. podia falar destes, mas não é a mesma coisa. Aqui já está. Okay. Hello. Once again, beyond being the president of the faculty, I'm also the coordinator or the head of the Laboratory of Motor Behavior. I will do a very short introduction because we have several studies and we have several research lines. Mainly, we are divided in two main areas. One, which is more dedicated to sports and try to analyze motor behavior in sports, and other more dedicated to child development. So, very basically, the main questions that we aim to address in our lab are these four, which are right here on your right hand. How are movements controlled? How are movements learned? Which variables influence movements, and how do movements change throughout the lifespan? And one of the main areas of research that we have is dedicated to this, how to analyze collective behaviors in team sports. Mainly, we work with the rugby players, also with the football players. And one of the main goals that we have when we start this research plan is to try to capture when we have, for instance, a ball carrier and a defender in interaction. How can we create some kind of collective variables that allow us to describe the behavior of two or more players within a pitch? So we created, for this kind of research, we created an angle between the defender and the ball carrier, and that angle, the evolution of that angle across time, gave us a description of what happens during the interaction between this ball carrier and the defender. And with a single variable, it is possible to describe when a tackle will occur, or, for instance, in the opposite side, when the ball carrier aims to dribble past the defender and runs towards the try line. Another research line that we have, more recent one, was trying to create some kind of landscape based on kinematic data, the positional data of the players during an entire match. We tried to create some kind of a heat map that allows us to visualize where the teams create more passing opportunities. And we are talking about passing opportunities, not passes that really occurred. So based on the position of the ball carrier and the closest defenders, we can see gaps where the ball carrier can pass the ball to the support player. Well, this is some kind of a footprint we create. For each moment on time, we can create a footprint of the passing opportunities. By overlapping these footprints, we can create these heat maps that you can see here. It's interesting to note that the team which is in the top creates some more passing opportunities in the midfield of the opponent team, more, well, a little bit biased to the right side of the attacker, whereas the team in the bottom can create passing opportunities all over the field. Another study that we have, when we aim to access what kind of perceptual variables or what kind of perceptual systems are important to maintain performance, we create some experimental design where we include the participants with that kind of perceptive source. This is an example that a study that we have done a few years ago in basketball, where we try to analyze if the peripheral vision that the players might have while are dribbling a basketball, if it is important or not. So we put the participants dribbling in a steady state position with some kind of goggles that cannot see the balls which is below. And we will see if these affect the movement of the upper limb or not. It is interesting to note that the most skilled players create some kind of increased variability in the shoulder and in the elbow in order to maintain the stability of the hand while they are dribbling. This is some study that, one of the first studies that we did, trying to analyze the interaction between a performer and a device. This is one of the prototypes that we developed. We try to capture the interaction. We put some sensors on the mountain bike, and some sensors also on the biker, trying to create some kind of variables that can explain the interaction between two. Currently, we are trying to develop also based on accelerometry. We are trying to create these kind of variables, not in the mountain bike, but in alpine skiing and also in motorbiking. This is a study that was made a few years ago when we tried to analyze if synchronization between rowers, how the synchronization between rowers was influenced by the frequency of rowing. And it is interesting to note that during the lowest frequencies, and obviously during the highest frequencies, is where the rowers were less synchronized. So it seems there is some kind of optimal frequency where the synchronization between both rowers was really, really good. This is a master thesis that was in collaboration with the Groningen University. So now passing more for the other area, more dedicated to child development, perception, action, and action in risky environments is something that we try to analyze and keep on going with these kind of studies, especially with something that is a little bit dramatic, which is why some toddlers may fall in the swimming pools when they are without parental vigilance. And also, Rita Cordoville, which is the researcher who developed this kind of works, tried to analyze where the young children are able to pick up some kind of books or some kind of objects that might be a little bit damaged for them. She also analyzed these based on the perception of the parents, if the parents have the right perception of the reaching and the grasping of the kids or not. Unfortunately, this is one of the research lines, my perspective, one of the most fun research lines that we have here on the lab. Currently, it is stopped, but Rita tried to analyze the behavior of the babies while they are approaching to a cliff, a visual cliff. She did this without water and also with water, and she tried to capture depending on the stage of development of the kids, they approach differently and they can speed up and go straight to the cliff, or no, they can stop, wait a little bit, because they can visualize there is a cliff over there and they change the behavior based on this constraint, this visual constraint. One of the major concerns that we have, especially nowadays, is trying to create a battery that can allow us to access the motor competency of children. This is something that was created also in collaboration with other universities and other researchers, but especially nowadays that people, especially the young ones, spend too much time with sedentary behaviors without a decrease, where it happens, a decrease in the active lifestyle. They try to address the motor competency and how the motor competency can decrease along the years. This is an example of the study that was developed by Rita and his team during the COVID time, and we can see that the motor competency after the COVID, post-COVID, it decreases a little bit in all the evaluations that was performed on that time in boys and also in girls. Children's mobility is a major concern that Rita and his team also have, how people can move within a city when they go to the school, if they use the playgrounds or not, and for how long they use it. Also, we have some kind of concern, especially now that Fabio Villanova started working with us, and adaptive sports and rehabilitation is something, is a new area for us, and we're trying to develop some kind of research on this. The sweet therapy is one of the examples that we have it here. Another example is the leisure activity in children and adolescents with cerebral palsy. Affordances for motor behavior of school children, how the children can use and see the affordances in the playgrounds. Social emotional competency and mobility in preschool children is another research line that we have it here. Also, how can we create play environments, and how the play environments are related with child development. We know that nowadays, well, fortunately, I think that the things are changing a little bit, but when we create some kind of playgrounds which is very narrow in the kind of activities they can explore with low diversity and low variability, this for sure will have some kind of consequences in the child development. This is a very interesting study that was performed, I think, 4 to 5 years ago, and the main goal here was to assess whether it is better to use this kind of bicycles with no pedals or the most classical bikes with the pedals. Which one is the best for people learn how to ride a bike? And I think, if my memory did not fail, I think that the results point that first, people need to learn how to balance in a bike, so without the pedals. And just later, after they acquire some kind of balance in a device, which is a little bit strange, we can add the pedals, and then they can use it more, especially to increase the velocity. Again, infant swimming and early aquatic experiences is a major concern that we also have here, and we have some PhDs working on this area. And basically is this. If you are, well, satisfied, and if I can raise your attention, so feel free to contact us, okay? And again, as Annalisa just said, if you want to see some kind of potential collaborations, we are very, very open, especially because we are building new facilities here, which will be world top for research. Okay, thank you very much for your attention. Paul, blessings. Now it's for you.
Good morning. First, I'd like to thank the organization for inviting us to present our lab, the Exercise Physiology and Biochemistry Laboratory. We are one of the labs in this faculty, and I will be briefly talking about our mission, our methodological capabilities, our current collaborations, and their work today. Well, of course, on the top of our mission, we have to produce high-quality scientific evidence in physiology and exercise physiology, exercise biochemistry, and kinanthropometry. But importantly, we have our lab as a strong aim to translate this science into sport and exercise applications. So most of our work is done in applied contexts within training and in collaboration with sports and federations and other sports stakeholders. Our aim is to provide evidence and knowledge to optimize performance, sports performance, also to support health and athlete development, including young athletes, which is one of the main areas, of course, of expertise in the lab. When relevant, we also contribute to injury prevention, support injury prevention, and also young talent identification. Well, of our main aims also is collaborate with the elite sports stakeholders and contribute to training the next generation of sports scientists through our undergrad students, master and PhD students as well. Okay, this is a schematic overview of our lab. Our lab combines three main scientific areas. It combines exercise physiology, exercise biochemistry, and also kinanthropometry, growth, and maturation. These were, in the past, there were three different labs that were merged together, and of course, we still maintain our, each of these areas has its own specific expertise, but we also try to work together in collaboration, and this is one of our strengths. Well, some of our scientific scope and research lines. Of course, on top we have classic, this broad overview of studying and understanding exercise responses and adaptations to training, sports training and exercise. And we do this pursuing a few complementary lines. One is muscle bioenergetics and fatigue. I have to say that, of course, we use mostly non-invasive techniques and indirect techniques to investigate this phenomena, this muscle bioenergetics, fatigue. Also, we pursue a more integrated systems physiology, so this is quite fashionable nowadays. We try to combine physiology, biochemistry, but also neuromuscular, even biomechanics, even behavioral knowledge, try to understand this exercise responses and adaptations. We also have a particular interest in nutrition, in sports nutrition, supplementation, and how these factors affect performance. So our aim, of course, is mostly to enhance performance, improve performance, and coaching decisions. Our lab also has a particular expertise in kinanthropometry and growth and maturation, and how this is related to performance. So we can measure maturation, growth, and study the relationship between these and exercise responses and young athletes' development. And also, and this is of key importance, we also have a very strong interest in environmental physiology. So, and in this mostly hypoxia and hypoxic training, and as well as heat, the impact of ambient heat on performance is a major interest in our lab. Okay, here's some of our methodological capabilities or skills. So, of course, we are an exercise physiology lab, so we have cardiorespiratory and metabolic testing using mostly a portable metabolic card, which is important because most of our studies are done in applied settings, so outside the laboratory. So we can measure, we can assess cardiorespiratory and metabolic testing in many different settings and contexts. Also body composition and anthropometric profiling. Body composition usually using anthropometric measures and bioelectrical impedance. And also we have quite, I would say, I don't want to overstate it, but quite a large panel of biomarkers to assess inflammation, immune function, and redox markers. Probably one of the first labs with biochemistry and with my colleague Stina Bent, who has developed several biomarkers to investigate the oxidative stress in sports. Of course, we have some equipment to measure body and environmental temperature. Some of this equipment is with a collaboration we have with other labs that we can have, like with telemetry, to non-invasively measure core temperature. And we can also measure ambient temperature. Of course, as Pedro said, we have these new facilities being built, and maybe in the future we'll have a heat chamber and an environmental chamber that we can pursue this kind of research. Okay, also important, we have very specific interest in performance modeling and individualized monitoring. So, and this is combining not just laboratory-based data, but also field-based data. So we collaborate with performance departments in clubs, in football and elite clubs, and to develop this kind of models to predict performance and also injury risk. And we also have the ability to measure maturation and skeletal age. So this is, I mean, it's a very important kind of skill we have in the lab, that we use X-ray, hand X-ray to determine skeletal age and to investigate young athletes and young talents. And okay. We have several equipment to pursue these methods that I've explained. We have a few ergometers and a treadmill. I already mentioned we have a portable metabolic system. This is called COSMED Kappa 5. You can see it collecting data from a swimmer, which is always difficult. We use near-infrared spectroscopy, continuous wave near-infrared spectroscopy to measure muscle oxygenation. We also use equipment to measure cerebrovascular function, but is in collaboration with other labs in the faculty. We also have a bioelectrical impedance device, and we have a dedicated X-ray imaging system that is operated with also a computerized radiography digitizer to perform X-ray of the hand and determine skeletal age. From biochemistry, we use a photometric plate reader, so it's for our ELISAs. Most of our assays are ELISAs, commercial ELISAs. And also a UV visible light spectrophotometer for other biochemical analysis. Okay, population settings and applications. So our population, the study populations are mostly athletes, some of them elite athletes, and the context is mostly in sports performance, coaching and performance. As you understand, because we study maturation, we also have young athletes as an important population in our studies, adolescents, studying growth, maturation, and the relationship with performance. We conduct laboratory control studies, protocols, but also we are engaged in field-based sports and training environments. This is also an important component of our research. We also conduct studies in what we say extreme environmental conditions. So using most often hypoxia, and most recently also we have a study that conducted an assessment in a hyperbaric environment to assess recovery from training, from exercise. Also heat, it's an important area that we want to, in the future, probably explore a little bit more. Our settings is mostly the lab, as I said, and also the field. So we have collaborations with clubs, federations, and coaches and practitioners, which is very important to us because it allows us to recruit participants, explore new research ideas, and most importantly, translate this knowledge into practice. So into sports coaching and monitoring, performance monitoring. Looking ahead, in the future, we want to develop more in depth this personalized exercise and precision exercise and precision physiology and biochemistry. This is aligned with our involvement with the exercise precision group of our research center. Also, more integrated multi-system and multimodal assessment of exercise responses. So this means that we want to combine not just exercise physiology, not just cardiorespiratory and metabolic assessment, but combine it with other measures, neuromuscular, biomechanics, motion capture, and also studying across different organs, muscle, brain, cardiorespiratory function. Of course, we want to keep developing our lines studying environmental stress, adaptation to environmental stress, heat, hypoxia, very important, hypoxic training, and how this affects performance, recovery, and adaptation. Of course, we want also to develop better models, predictive models for training and performance, combining laboratory-based data with field-collected data. Of course, this is not that we have already very models for each person or for each participant, but this is like a goal, a direction we want to take. And of course, translation of the lab evidence into sport and exercise practice, and I place in brackets, this is citizen science, because we have many participants, many people nowadays practicing exercise every single day, using wearables, etc. And so there are a lot of data being collected outside the labs, outside the faculty, so we can maybe bring this data in. We have collaborations. Collaborations are, of course, of key importance for the lab success and our work. We have scientific collaborations within the faculty and also within our research center with colleagues in Lisbon and colleagues in Coimbra. We have applied collaborations with several sport federations, the Portuguese Football Federation, triathlon, swimming, and others. And also with clubs and with the performance departments of elite clubs or in Portugal. We, of course, have a role in training undergraduate, masters, and doctoral and postgrads, and community engagement and scientific dissemination, publications, conferences, and other events. Okay. Some ongoing projects to illustrate what I've been saying. We have like a major project with these strategies to optimize hypoxic training in elite athletes. It's in collaboration with the University of São Paulo and also with our center, nearby Center for High Performance. Also an important project of one of our PhD students studying durability in elite endurance athletes. This is in collaboration with the University of Agder in Norway and focusing on the role of respiratory frequency as a sensitive biomarker of performance decline. Also a study looking at the maturation profile of Portuguese female footballers, players in collaboration with the University of Coimbra. Small projects. One is to investigate cerebrovascular responses to sprint exercise in collaboration with SPERT Lab, which is one of the labs also here in the faculty. And also small study, although to look at physiological and hormonal changes during weight cutting in female wrestlers. Nowadays we are moving more to study female athletes. In the past, as you know, most of the participants were male. Okay, so to sum up, So our lab mission is to integrate physiology, biochemistry, kinanthropometry to better understand performance and optimize exercise and sport performance, and through not just research, but also training and also applied collaboration, which is very important for our lab, and also through knowledge transfer. I have to thank you for your attention, and of course I'll be in the lab for your visit, so you can ask any questions if you want, and we can talk also, of course, about collaborations. Thank you.
Good morning to everyone. My name is Paulo Santos. Professor Raul Oliveira and Professor Gonçalo Mendonça, who is the director of the Neuromuscular Research Lab, they couldn't be here, so I'm here representing precisely the Neuromuscular Research Lab. The purpose of this short presentation is to provide an overall overview of the work we conduct at the Neuromuscular Research Lab, namely concerning the main research lines, the research methods and the equipment we use, and of course some examples of previously performed studies. So our lab is composed by 5 PhD formal members, Professor Gonçalo Mendonça, Professor Raul Oliveira, Professor Maria João Vala Matos, Professor Sandro Freitas, and me, and of course the students that are doing their PhDs and master courses. So the lab has 8 years of existence, and since the start of the lab, 16 students completed their PhDs, 61 students completed their master courses, namely concerning exercise and health, but also high performance training, and we are able to complete 8 editions of the 1-year post-graduation course in strength and conditioning. Finally, over the 8 years, we were able to publish 211 articles in peer-reviewed journals with impact factor. It's not working. Sorry. It's not working here. Sorry. Okay. Okay, thank you. I was saying the primary research lines we are following in our lab are of course connected, and are the 5 that are presented here. First, we study the mechanisms as well as the adaptations on neuromuscular function to training. Also, we are focused on the optimization of methods used to evaluate neuromuscular function, as well as strength and flexibility. Also, the identification of neuromuscular injury predictors and potential changes after movement disorders, as well as sexual dimorphism, and of course, Powerpenia and the neuromuscular mechanisms underlying the age-related losses in power and also strength. As it is well known, neuromuscular function depends on the neural aspect related to the central nervous system and the whole nervous system, namely concerning the intermuscular coordination, and also spinal reflexes. We currently are researching about the control of the eye centers of the central nervous system, and on the other hand, the muscular adaptations to training, namely concerning muscle size, muscle stiffness, and muscle architecture. So these are examples of the research methods, the research equipment we use in our lab, namely concerning force platforms, linear encoders, contact maps, kinematic analysis, for example, the use of brightness mode of ultrasound imaging, isokinetic dynamometry, peripheral electrical nerve stimulation, and lots of electromyography, monopolar, bipolar, and currently high-density surface electromyography systems. It's not in the image, but also we have performed some studies with electroencephalography, and yesterday it arrived a new equipment of transcranial magnetic stimulation, so we can assess the corticospinal pathway. So I will present examples of some of the previously performed studies in our lab. For example, one of the research lines we were focused over the last years was concerning the extraction of EMG, electromyographic patterns, between different muscles in specific motor tasks, as for example, the karate punching, the golf swinging, or breaststroke swimming. Usually, these studies compared athletes with different levels of expertise to a better understanding of the chronic adaptations of the elite athletes when compared to the others. Also, concerning injuries, some studies about muscle predictors of low back pain in athletes, namely concerning some sports as tennis or golf. For example, here I provide some examples of EMG spectral decomposition and machine learning methods to assess the association between low back pain and different electromyographic patterns during some force production and movement tasks. Also, hamstring injuries were also studied in our lab with the expertise of Professor Sandro Freitas, namely concerning the technique of shear wave elastography. Some studies were published considering the differences between previously injured athletes at the hamstring level versus uninjured athletes. It's an example of a photo of the setup of the assessment of the muscle stiffness of the hamstrings. And also some recent studies showed that the cortical control in these athletes with previous injury is also altered when compared to the uninjured athletes. Also, some examples with different training approaches, for example, the use of some equipment more related with sensory motor training. Also, a topic that was extensively studied in our lab, the effects of blood flow restricted exercise. For example, some studies compared the effects of low intensity resistance training with blood flow restriction with high intensity training without blood flow restriction, and it conducted to several publications. Now, concerning other topic that is particularly interesting for me, some of these studies comprise my doctoral thesis, the study of intermuscular coordination, namely with the extraction of muscle synergies and intermuscular coherence calculations. One of the topics that is really studied in the past few years concerning the adaptations to strength training is the role of intermuscular coordination in the gains of strength. Here, for example, we performed some studies compared athletes with different levels of expertise. For example, in the power clean, that is a task derived from the Olympic weightlifting movements. And also we performed some longitudinal studies where individuals trained over the weeks and were reassessed at the ending of the protocols. Also concerning sexual dimorphism. For example, in the past, we did a systematic review about the long-term adaptations to resistance training, and from the more than 20 studies included in that revision, only one evaluated females and males. All the other studies only evaluated males. So usually we generalize what we know about the research made in male individuals, and we generalize it to female population. And as we know, there are neuromuscular differences that may lead to an unoptimal solution. So we performed some studies, for example, concerning neurophysiological parameters, namely the age reflex and V-wave. We also studied the responses to fatigue concerning isokinetic contractions at different velocities, also muscle fatigue concerning the adaptations to blood flow restricted exercise, and also the influence of sex concerning the load velocity profile in the squat. More recently, and as the final research line I presented before, it emerged the concept of Powerpenia as the decrease of motor power associated to aging, disability, or physical inactivity. Those two articles were published in relevant journals, and that's the reason why we will be together during the next 3 days. Just some complementary research lines that were also conducted in the last few years. The effects of intermittent fasting on exercise performance, the effects of sleep deprivation, the interference of concurrent training in the development of strength and neuromuscular adaptations, the effects of velocity-based versus percent-based training on muscle adaptations, and the acute and chronic analgesic effects of different exercise regimens. To conclude, I just want to mention our post-graduation course. It's a 1-year post-graduation in strength and conditioning, training, and rehabilitation. And finally, I just want also to mention that in the previous years, some members of our laboratory also published 2 books concerning strength training. One, the volume 1, more focused on the physiological fundamentals of strength training prescription, and a second volume more related with prescription for different populations. So thank you so much. I will be able to talk with you a little bit more during the visit, okay? Thank you.
Okay, now that you had all the presentations, very theoretical, let's go to the practical. So we have more or less here 30 people, maybe we'll divide into groups, and we'll meet all these labs. You can touch in everything, but don't abuse, okay? So see you there outside.